Absolute value. One very simple definition of the absolute value of Q, written like this with two vertical lines, is that it makes it positive. That is, if I was looking at the absolute value of -4, that equals +4. And the absolute value of +5 equals +5. So if it's positive already, it leaves it alone, and if it's negative, it makes it positive. There is also a useful geometric interpretation of the absolute value, given below. The absolute value of Q is Q's distance from 0 on the number line. That is, if the absolute value of Q equals 3, then Q is 3 units away from 0 on the number line. So the absolute when you say the absolute value of Q equals 3, then Q has to equal either -3, because that's 3 units away from 0, or +3, which is 3 units away from 0. Thus, I should say Q itself, shouldn't I? I'll fix that. Thus, Q, capital Q, itself is +3 or -3. Notice that this still works for the above examples in the simple definition. In other words, this new definition still works. If we're looking at the absolute value of -4, we see that -4 is 4 units away from 0, so it's +4. And the absolute value of +5, that's 5 units away from 0, so it's +5. So it works for in the old definition too, the simple-minded one. And here we go. Let's take a look at a problem here. Okay, given the problem, the absolute value of x plus 2 equals 5, this x plus 2 plays the role of Q. And we can immediately write that x plus 2's distance from 0 equals 5, or it could equal -5. Solving for x in both cases, I assume you know how to solve this, x equals 3, or x could equal -7, and they'd both solve this absolute value equation. The same is true for absolute value inequalities here. Let's move this up a little bit, okay? The absolute value of 2x minus 7 less than 10 says that the quantity 2x minus 7 is less than 10 units from 0. Therefore, this quantity, which plays the role of Q, must be trapped between -10 and +10. So here it is. It's trapped between, it's greater than -10, but it's less than +10. And we have one of these sandwich inequalities. You solve these by working with 1, 2, 3 sides. Of course, you add +7 to each side, and you end up with this expression, and this reduces to -3 less than 2x less than 17. And then we divide all three sides by +2. As long as you're dividing by a positive number, you don't have to reverse the inequalities. And we find that x must be greater than -3 halves and less than 17 halves. With the problem, the absolute value of 4 minus 3x being greater than 10, this means that 4 minus 3x's distance from 0 is greater than 10 units, or that this quantity is greater than 10, or it is less than -10. That's how you become more than 10 units away from 0. Solving the two linear equalities, we get x equals -2 or x equals 14/3. And here are the rules that we've devised for absolute value quantities problems. Below are the three rules where Q is any quantity and K is a real number and K is greater than or equal to 0. So the absolute value of Q equals K implies that Q equals K or Q equals -K. The absolute value of Q is less than K means that Q is trapped between -K and +K. And if we say the absolute value of Q is greater than K, then Q is less than -K or Q is greater than K. And all of this involves Q's distance from 0.